So in this video, we are going to look at radial surveys. Now I've got a definition for a radial survey down the bottom here. Now basically a radial survey is used to create a diagram of a piece of land that is in the shape of a polygon. So it's a way of basically estimating different areas of land, different lengths, so perimeters of land, but it essentially involves drawing lines from a center point reaching out to the corners of the polygon. Now, with all polygons, we know we can break it up into smaller triangles. So what we're essentially going to be doing is a radial survey is going to be like a bird's eye view, for example, of a block of land. And we are looking at calculating areas, perimeters of this land using what we know from non-right angle trigonometry. Now in example 1 here, you can see a piece of land. So it's asking us, what is the area of triangle ABC? Now triangle ABC is this large triangle here, but we have a few little measurements that we've collected for these three small triangles. So we have triangle AOC, AOB, and COB. Now remember, we can find the area of a triangle by doing half times one side times another side times the sine of that included angle. So we're going to be taking essentially smaller areas of these smaller triangles that we see here. Now I've already done the working out for you to see because it is just the same formula. Remember the formula for the area of a triangle is half times A times B times sine C. So for triangle AOC, this one here, we have half times 5 times 4, that's the other length, times the sine of 136. AOB, we have half times 5 times 7 times sine 82. And COB, same thing with 4, 7, and sine of 142. So we can essentially find the area of each of these individually just by putting it into our calculator. So for the first one, we get an area of 6.9466. Let's round it. Second one, we're going to do the exact same thing, except we're doing sine 82 and we're multiplying 5 by 7. So we get 17.3297. And then the last one, we have sine 142 and we're multiplying 4 by 7 by half. So here we get 8.6193. So if we want to find the total area, all we have to do, we found these individual ones, is we just have to add them up. So the area of my triangle ABC is going to be 6.9466 plus 17.3297 plus 8.6193. So we are just adding all of these together. So adding them in using a calculator, plussing them all together, 6.9466. We get, and it's asking us to one decimal place, this is going to give us 32.89 ... which gives us 32.9. And our units, it's in meters. So it's going to be this, meters squared. So we are just finding the area of the triangle, applying our formula for the smaller ones, and then just adding them together to find the total area. Now for the second one, this is where we add bearings, right? So we have to remember what we talked about in bearings. Now this question's quite scaffolded, right? So it gives us all of the steps to build up to this part here. What is the perimeter of the field? A harder question in an exam may just ask you this right off the bat, and you have to think how you are going to apply what you've learned in trigonometry so far. Now, this is saying, what is the size of angle POQ? So I'm looking for POQ. Now, with a radial survey, we have a few true bearings here. So measuring from north, I know that this angle here is 72. That's what this part tells me. Now, 145 degrees true bearing is this angle here, this obtuse angle. If I want to find POQ, I just have to take this angle minus this angle here. So POQ is going to be 145 minus 72. And that is going to give us 73 degrees. So we are subtracting the smaller one from the larger one. That's going to give us this angle in here. This is the trickiest part about finding the angles in these radial surveys. We have to remember to subtract. Now, triangle POR, that is this entire angle here. Now, we're going to find these each individually. Now, if we know that at this point R, it's at an angle of 290 degrees, that means that this whole angle up to here, this reflex angle, is 290. Now, we know an entire revolution is 360. So this angle in here is just going to be 360 minus 290, which is going to be 70 degrees. And we're already given this angle here, NOP, as 72, because that's what this number tells us. It tells us the angle of this point from north is 72 degrees. So this guy in here is 72. So that means POR, that entire angle, is 72 plus 70, which equals to 142. So we are finding the length of, because to find the perimeter, that's what we're building up to, we need to add 4.7 by 4.5 plus PQ plus PR. So we are finding these in part C. Now, for PQ, we've already found this angle, 73 in here. This angle in here is 73. We found that in part A. We can use our cosine rule, because remember, we have one side, which we need to find, and two given sides. 3 sides, one angle, we're using cosine rule. So PQ, I'm going to go straight into square rooting, because remember, the last step for cosine rule is to square root. But PQ is going to equal the square root of 4.8 squared plus 4.5 squared. So it's a squared plus b squared minus 2 times a times b. A and b are just those two sides. Times cos of 73. And it's asking us for this to 2 decimal places. So this entire thing we're going to put into our calculators. So 4.8 squared plus 4.5 squared minus 2 times 4.8 times 4.5 times cos 73. So this gives us 5.54 to 2 decimal places. Next one, length of PR. So D. PR, I'm using the value that I found in part B, because I have, that is my angle in here. And to find PR, I have one side, another side, and a third side. So 3 sides, one angle, cosine rule again. So PR is equal to the square root of 4.7 squared plus 4.8 squared minus 2 times 4.7 times 4.8 times cos of 142. And once again, we're going to put this in our calculators. So we have the square root of 4.7 squared plus 4.8 squared minus 2 times 4.7 times 4.8 times cos of 142. So we get 8.98. Okay, so we've found these now. So PQ we said was 5.54. This one was 8.98. To find the perimeter for part E, we just add all of these together. So for part E, we have 5.54 plus 8.98 plus 4.5 plus 4.7. And that's going to give us our perimeter. So we go 5.54 plus 8.98 plus 4.5 plus 4.7 and it's asking for an answer to to 3 significant figures. Now we get 23.72. Now we have our first significant figure, our second significant figure, our third significant figure here. So that is going to be 23.7, and our units are in meters. And that is how we can use our cosine rule, our area of our triangle, and a whole bunch of other applications of previous non-right angle trig we've been doing to find areas and perimeters of radial surveys. Now, remember, like I said, a question may just give you this last part. What is the perimeter of the field? And it's up to you to find all of these small angles, apply your cosine rule, and then find the perimeter. But always look out for the little hints. Like I said, 3 sides, 1 angle, we're always going to use cosine rule. But that brings us to the end of the video. Thank you so much for joining me, and I'll see you next time.